So what if the AI you talk to every day already knows what it's going to say next, and we just figured out how to listen in? That's the secret behind some incredible new research from Apple that could make these language models up to 5 times faster. Let's break down exactly how they pulled it off.
You've been there, right? We've all been there. You ask a chatbot a question, and then you just wait. You're watching that cursor blink, and the response just trickles out. It feels agonizingly slow, almost like you're watching someone hunt and peck for every single letter on a keyboard.
And look, that feeling isn't just in your head. It's actually fundamental to how these AIs are built. Most of the language models we use today are designed to think sequentially. They write one word, then they pause to read everything they just wrote, and only then do they figure out the very next word. It's a very deliberate process, but it's also the reason it's so slow. Now, there's a fancy technical term for this one word at a time method. It's called autoregressive generation. And while it's the gold standard for building powerful, accurate models, it comes with a huge performance cost. Every single word needs a full, really computationally expensive pass through the entire model. And that creates a massive bottleneck. This is where things get really interesting. This is the big question this new research asks. What if the model didn't have to work that way? What if, kind of like how we speak, it could anticipate an entire phrase or even a whole sentence before it even starts typing? And asking that one simple question, well, it led the researchers to a pretty fascinating discovery. They realized they didn't need to build some brand new capability from scratch. The potential they were looking for, it was already hiding inside the models all along.
And here it is. This is the core secret. These language models, they already have a kind of fuzzy, almost subconscious idea of where their sentences are going. This latent knowledge about the future is already in there, but it's messy. It's like having a brilliant idea that's buried under a giant pile of disorganized notes.
Okay, this slide right here, this is the aha moment. On the left, you see a standard model. If you ask it what is 2 plus 2, the words that will eventually form the answer, like equals 4, are totally lost. They're buried in a sea of hundreds of other possible words. But now look at the right. After some really clever training using these special mask tokens, those exact right words suddenly jump right into the top 10. The model's vague intuition just snaps into a clear, predictable plan.
And don't just take my word for it. This is what the researchers themselves said. And it's really the key. The ability to see the future was there the whole time. The real challenge wasn't creating a new skill. It was just figuring out how to unlock it and organize it.
So, okay, if the potential is just sitting there, how do you actually use it? Well, that required a brilliant new toolkit, designed specifically to harness this hidden knowledge and turn it into a massive speed up. Their whole solution really comes down to 3 key parts that all work together. First, that mask training we just saw, which teaches the model to predict a whole chunk of future words, not just one. Second, a super important safety mechanism called Gated LoRA that adds this new skill without breaking anything. And finally, a lightweight sampler that basically acts as an editor to make sure the final output actually makes sense. Let's focus on Gated LoRA for a second, because this is the real linchpin of the whole operation. You see, if you just try to jam a new skill into a complex model, like on the left side, you risk messing up everything it already does well. It's a really risky path, but Gated LoRA on the right is way smarter. It acts like a special bypass lane for this new skill, so it only gets used when needed. And this is so crucial. It guarantees that the model's original quality and accuracy are perfectly preserved.
Okay, so now the model can predict a whole chunk of words all at once. But does that chunk actually make any sense? Well, that's where the sampler comes in. You can think of it as a coherence coach. It's this tiny, super efficient module that looks at all the words the model predicted and arranges them into a logical, flowing sentence, making sure the output is always top-notch.
All right, the system is fast. It can generate a whole block of text at once. But that brings up probably the most important question of all. How do we know that block of text is actually correct? This brings us to the final and absolutely crucial piece of the puzzle, the verification step.
The solution here is a process called speculative decoding. And here's the gist of it. The new fast model generates a draft with multiple words. Then, in a single super fast step,
It uses the original, untouched part of the model to check if that draft is exactly what it would have said anyway, just one word at a time. It's like having a student write a quick draft and a teacher instantly fact-checking it. Now, the researchers actually tried two different ways to do this verification. The first one, on the left, is linear decoding, and you can think of it like a fragile chain. It checks the words one by one, and if it finds a single mistake, boom, the entire speedup for that chunk is lost. So they came up with something much better, quadratic decoding, on the right. This is way more like a safety net. By cleverly arranging the checks, it can find an error, fix it, and keep on verifying the rest of the draft. This leads to way more consistent and powerful speedup. So we have a way to find the hidden knowledge, a safe toolkit to activate it, and a robust system to verify the results. So after all that, does it actually work? Let's look at the result. And the results are, well, they're staggering. In the best-case scenarios, like on highly predictable tasks such as coding, this new method achieved a 5.35 times speedup. That isn't just a small improvement, that's a massive, massive leap forward in efficiency. And this isn't some one-trick pony either. As you can see from this table, the gains are significant pretty much across the board. For super predictable stuff like math and code, you get that insane 5x speedup. But even for more creative and conversational tasks, you're still getting a really impressive 2.5 to 3 times boost. It just works, everywhere. This chart really shows why their entire toolkit is so brilliant. As you can see, each component adds another layer of performance. The basic method by itself, that gives you a decent boost. Then you add that safety net of quadratic decoding, and things get even better. But it's only when you combine every single piece of the toolkit together that you unlock that maximum speedup. Every component plays a vital role. But here it is. This is the single most important part of this entire breakthrough, and it's pulled directly from the paper. Thanks to that clever verification system, these incredible speedups come with absolutely zero loss in quality. You get all of the speed with absolutely no compromise on accuracy. So ultimately, what this research really does is teach an AI to think ahead. It's moving from generating word by word to thinking more phrase by phrase, a process that's actually much closer to how our own minds work. And it leaves us with a pretty provocative final thought. We just unlocked one human-like efficiency that was hiding in plain sight. What else are these models capable of if we just know how to look?